Good day. Today we want to present our group project of subject BEE20303 Multivariable Calculus. We are from group 9 of section 6. Our group members are Nurul Naziha, Qin Jin Sun, and Sun Wei Song. The first question is from Final Examination Sem 2 2020 to 2021. The first question is compute the multiple integral of the following given. By using the integrand and the range of the region given, we can easily find the answer of it. The answer of A1 is 203 over 120, and the answer of A2 is 76 over 3. For the simulation part of the question 1A1, firstly, we do the inner integration with respect to x for the integrand xy, and then we will do the middle integration with respect to y to the answer of the inner integral, and later we do the outer integral with respect to z for the answer of the middle integral, and then we will get the answer which is 203 over 120. And we also use the same step as A1 for the question A2. Firstly, we declare the integrand which is x minus x squared minus y squared, and then we do the integrate with respect to y for the integrand first, and then we do the integral with respect to x for the answer of the integral with respect to y, and then we get the answer which is 76 over 3. For question 1b, we need to evaluate the following triple integral by using spherical coordinates. From the upper limit of z, we can find out that the range of the row is between 0 to 4 sub 2. And we also found out that the range of the theta is from 0 to 2 pi. And by using the equation of x squared plus y squared plus z squared equal to rho squared, our integrand for the spherical coordinate is 3 rho squared. And for the lower limits of the z, we found out that z is equal to sub x squared plus y squared. Since sub x squared plus y squared is also equal to r, so z is equal to r. And z is rho cos phi and r is rho sin phi. So rho cos phi equal to rho sin phi, and at the end we get phi is equal pi over 4. So the range of phi is between 0 to pi over 4. And we change dv become to rho square sin phi d rho d phi d theta, and we can get our answer is 24576 pi over 5 times 2 minus 1. For the simulation part, we define the integrand first, and we key in the upper limit and the lower limit for the integration, so we get the answer same with the manual calculation. For question C1, we need to find the region R by using the polar coordinates. By using the equation of the circle given, we can find out that the range of R is between 1 to 2, and since the region is in first octant, so the range of phi is between 0 to pi over 2. Since x squared plus y squared is equal to r squared, so our integrand is r squared. And we change dA to r dr dv and do the multiple integration, so we will get our answer is 15 pi over 8. For the simulation part, we define the integrand first, and later we key in the upper limit and lower limit for the multiple integration, and at the end we also get the answer is 15 pi over 8. For question 1C2, we need to use double integral to find the area of the region. By convert the x and y inside the graph, we use vertical strip integration to find the area of the region. The interval of y is between cos x to sin x, and the interval of x is between pi over 4 to pi over 2. By using this information and do the double integrals, we can get the answer, which is sub 2 minus 1. For the simulation part, first we define the integrand and we key in the interval of x and y. At the end, we get the answer, which is pi over sub 2 minus 1.
Good day to doctor. My name is Song Wang. So I will continue for the presentation of question 2, final exam sem 1 2021-2022. So for this question, it needs us to find the volume under the surface z equal to 3x cubed plus 3x squared y over the rectangular, which is also given the range. So as this question already given the range and also the equation, so we can directly put into the formula, which is b equal to double integral of z dA. For dA, we can either choose dx dy or dy dx. So for this question, I choose the dy dx to solve the question. And lastly, I get the answer 172 units square. And right side also will be the verification of answer, which is using the MATLAB coding. We can see that firstly we declare the range and also the equation. After that, we do the integration of dy, and next will be dx, and lastly we got the answer, which is 172, the same answer with the manual calculation. So for the question B, it needs us to find the surface area of the portion of the paraboloid given by the equation z equal to 1 minus x squared minus y squared that is above the xy plane. So we can know that as it says that that is above the xy plane, so we can say that z is greater than or equal to 0, and also x squared plus y squared is smaller than or equal to 1. So first we use the formula surface area equal to double integral and set of z dz over dx squared plus dz over dy squared plus 1 dA. So for the dA, we need to depends on the polar coordinates. So firstly, we using the z equal to 1 minus x squared minus y squared to do the differentiation to get the dz ds and dz dy. After the substitution, we change it into the polar coordinates, which is r. We change the x squared plus y squared equal to r squared. We change it to r squared. After that, we draw out the shapes, and we know that that will be the paraboloid, and we take the projection to the xy plane. We can saw that there will be a circle, and we change it from the Cartesian coordinates to the polar coordinates for our calculation. And next step will be the substitution into the formula to calculate the answer. And the answer after calculation will be the pi over 6 bracket 5 sub 5 minus 1. So let's take a look for the right side, which is the verification of our answer from the MATLAB. So as we can see that we declare all the data first, and after that we let them to calculate the answer and shows the answer of the surface and also in symbolic and also the numeric. So for the symbolic is totally same to our manual calculation. Okay, so next question will be the 2C1. So for this question, it says that an ellipsoid is given by the equation for x squared plus 4y squared plus z squared equal to 16. So it wants us to sketch the 3D graph and also its projection of the suitable plane. So for the manual calculation part, I divide it by 16 and we got it the general equation. So we can know that all the intercepts of the x, y, and z. And I choose the projection on xy plane. So we can get a circle shape on the xy plane as the graph shows. And also the below will be the 3D graph that I sketched is about the ellipsoids. So now part will be the verification of the MATLAB code. So after the code, we can see that the right side of the code will shows the answer of the MATLAB code. We can see that it is the ellipsoid and the circle will be the projection of the xy plane. Okay, so for the question 2C2, it needs us to find the volume of the ellipsoid using triple integrals by changing it to the cylindrical coordinate system. For now, the system will be the Cartesian coordinate system. So first, we need to change the x squared plus y squared equal to r squared. And then we found the range of the z first. And then we using the projection of the graph to the xy plane to find the range of r and also the phi. And next we substitute it all into the formula, which is v equal to triple integral r dz dr d phi. And after all the calculation, we got the answer will be 64 pi over 3 unit cube. And let's take a look for the right side part, which is the verification of the MATLAB code. So as first that we mentioned for all the data, after that we let it to display the answer of the volume in symbolic and numeric. So as we can see that the answer of the symbolic is same as us and the numeric will be the answer after change the pi equal to 3.1414159. And that's all from my part. So I will pass it to the next teammate to explain the next question.
For this question, we need to use double integral to determine the area of the region enclosed by the two lines. Firstly, we find the intersecting point of the two lines. Later, we can use vertical strict integration with the interval of x between -1 to 2 and the interval of y between the y max is 5 minus bracket x minus 1 square and the y min is 2 plus x, and use this information to do the multiple integral, and we can get the answer is 4.5 units.
So for the question Q1C 2001-2022, we got the same answer for simulation part, which is 4.5 units, which is the answer is the same with the manual calculations.
For question C2, firstly, we use the information given to sketch a diagram, and through the diagram, we can know that the interval of r is between 3 to 2. And since the surface area is in the first octant, so the interval of phi is between 0 to pi over 2. Later, we we use the equation of surface area to find it. And first, we need to solve for the integrand first. Later, we use the integrand and the interval we find before it to do integration, and then we will get the answer, which is pi units square.
For the question QC2, we got also the same answer, which is from the manual calculation. We got a pi unit. So for the simulation coding also we got pi for the answer, and on the surface area numeric, which is 3.141593. So for the simulation part, we already done and the MATLAB software, and then the answer we got after we run the coding, is it the same or not? So the answer is same with the manual calculation and the simulation, which is 8/3. As we can see for this simulation image, the A is equal to 2, so 2 times 3, which is we got the 8 and 8/3, the same answer from the manual calculation. So for the simulation part, we already done and the MATLAB software, and then the answer we got after we run the coding, is it the same or not? So the answer is same with the manual calculation and the simulation, which is 8/3. As we can see for this simulation image, the A is equal to 2, so 2 times 3, which is we got the 8 and 8/3, the same answer from the manual calculation. So for question B, the question asks to find the volume of a curved wedge which is a cut out from a cylinder x minus 3 squared plus 2 squared equal to 9 by the plane z is equal to 0 and zy equal to y. So as the first thing we need to do is we need to shift a coordinates, which is we need to let u equals to x minus 3. So after we let u, then we differentiate and we got 3, and then we switch to the polar coordinate. So the polar coordinate, which is u equals to r square phi, y equals to r sine phi. So after that, we use the volume formula to integrate the equations, the value of 9. After we integrate the value, before we integrate the value, we put value of 9 on the r cos phi and r sin phi. After that, we integrate both sine and cos, and we got the answer, which is 18 unit square. So and then from the simulation also, we get the same answer with the manual calculations. So for the question Q2C 2021-2022, for the manual calculation, we need to integrate the question for 3 times, which is the integrate, we need to integrate the z square, dz, dx and dy. So after we integrate all the value, which is 3 times, we got the answer 32 pi bracket 2 square root 2 minus 1 over 15. So for the simulation part Q2C, we also got the same answer, which is 32 pi bracket 2 square root 2 minus 1 over 15. So both manual and simulation calculation, we got the same answer. So okay, assalamualaikum. Okay, so for for this slide, we want to show we want to explain the step by step for question Q1A. So for this question, we can see in this problem, we asked to evaluate a triple integral step by step, and we will use a MATLAB symbolic. This is a MATLAB symbolic toolbox to compute each part of the integral and see both the exact symbolic result and the numeric value. So for SYMS first we declare the symbolic variable XYZ. This allows a MATLAB to treat them as an algebraic symbol rather than a numbers. So for this inner code, which is an inner integer x uh, multiply y, we start the inner integral with respect to x. The integral is a x dot y, x multiply y, and the bounds are from 0 to y. So evaluate this everything is x squared over 2 at the limits, which is a simplified of y 3 over 2. So for the next is a middle integral, which is integral inner simplified, which is the next integrate with respect to y. The bounds are from 0 to square root 4 minus z square. This step incorporate the geometry of the region since the upper bound depends on z. So for the result MATLAB, finally we integrate with respect to z from 0 to 1. This complete the triple integral. The MATLAB simplify the result to give us the exact symbolic answer. So for the DISP, we display the result in two forms, which is the symbolic fraction showing the exact algebra answer and the numeric value, which is useful for particulation calculation. So this step-by-step approach show how MATLAB can handle multiple integral symbolics, making it easier to verify each stage of the calculation and present both an exact and approximate result. So I can show that the value from this coding we get the same as a manual calculation. So let me run first. So after run, we got the answer, which is 20203 over 120 in the result symbolic, and then the result numeric we got 1.69166667. So that's all for me, and thank you.
That's all for our presentation. Thank you for your watching.